Hello everyone, welcome back to another Universe Sandbox video, and today we're going to be doing another episode of evolving a custom solar system from birth to death. So, if you didn't see the last episode, definitely make sure to check it out before watching this video. But yeah, now on to today's one. So, obviously, continuing on from last episode, our star is now larger than the sun. Remember, it had more mass to begin with, but now its radius is 5.91 suns. It's also becoming hotter than the sun, and it's also becoming more luminous. So we're probably going to go to a blue star phase before we eventually become a red giant and stuff. So this star's going to get very luminous. So we're going to see sort of what impacts it has on the system, because I'm pretty sure that habitable zone is probably going to be getting out to the ice giants at some point. So let's continue. So we'll let the solar system evolve a bit. We'll run the simulation really fast. And actually, just to pause, I think I saw a material trail coming out of this object here. Yes, and it's pointing at the star for some reason. What the heck? That's not seen that before. Oh my god, right. Let's slow it down. Maybe it's just because we were running the simulation so far. But as we can see, yeah, this object is losing. It is losing out to the star. It's losing material. We can see it's tightly locked, remember. So the front face of the planet is absolutely molten. Absolutely molten. So the clouds don't even show up in the daytime, which is pretty weird. They only appear once it starts getting darker, which is very strange. We can see a lot of material is being lost. So this object could be completely evaporated by our star eventually. So yeah, one of the hottest planets, and yeah, it's definitely in the danger zone of that star there. So not looking good at all here. I mean, you can see it's like the clouds disappear in the daytime. It's like the clouds evaporate in the day. I mean, that's really weird. So how hot is the front of this object? So as we can see, 840 degrees is the hottest point of this planet on the front face. So pretty crazy stuff there. Okay, so yeah, remember, that's our closest planet. Next planet out. So this was ideal. So we can see this object, just one of the more default ones, but it's still very hot like Mercury. It's also losing material, so not good. So these planets could, the two inner planets may not last till the end of the system anyway. They could evaporate before the star even becomes a red giant. Next up, we got hot ice. So as you can see, it's obviously 309 degrees, getting very hot here. So as we can see, yeah, 377 at the hottest point. So hot ice, there you go. It's kind of like 55 Kangaroo there. Or the planet that has burning ice because it's so like dense and it can't melt. So, right, how's a Lombi doing? This is our desert-like objects. This one's at 31 degrees, so it's actually at a comfortable temperature at the moment. So, not too bad. Let's have a look at its stats actually. So, 16 and 0.7. So, you know, not looking the best there. Remember, it is a desert world after all, so it's not really designed for life. But yeah, there it is. So it's getting cloudy. So there's a Lombi. Next up we had Venus, or the early Venus. So remember, this world, last episode we saw this world, it was habitable at one point. It did meet its, it did get the habitable zone, but now the star has passed past it, and its temperatures are starting to increase. So remember, this world was, well, it still is at the moment, it's still got its water, but that water's all going to evaporate eventually. So we can see that atmosphere is going to get thicker as the greenhouse effect increases. So this object's actually hotter than a Lombi, even though it's a little further away, so it's got more greenhouse. Next up, we have this object over here. I believe this was one of the Earth-like worlds at one point. Like Venus, it's now too close to the star for it to be at a good temperature. But at the moment, it still has water on it, but it is very hot at a blistering 113 degrees there. So as we can see, the coldest point is 36. So yeah, this world is not really habitable anymore, but it still looks really cool. So we're going to see how that world evolves through this system as well. And I think taking another jump out, the next object out was Earth-like, and this is currently the best place to sit, possibly. I know it's actually a little cold here, minus 58. Let's try and warm it up. Does it warm up? No, it still gets too cold. But yeah, this is currently probably one of the best spots for life in the system currently. So we can see it's got oceans, or got bits of water, it's got land. It's all everything you need, really. So there's that world there. I think the next world out, I think it was Captain B. I think this is also one of the spots for life currently in this system. Probably the best bet for comfortable life at this point in the timeline. So we can see 50.8, pretty much Earth-like conditions, got some decent stats there. So there you go. But now, obviously, that's probably the furthest we need to go. I think all the other planets further out are not really... Okay, so you've got this world as well, but this one's also at... But where did that world go? Did I just delete it? Let me put that back. Where did it go? Oh, no, never mind, it's there. Okay, so there it is. So, yeah, this world as well. Have a quick peek in it. So there you can see it's got oceans, it's got water, but it's still very, very cold. So not really at the area yet for one. And then we have Kepler 22b, also a frozen world. So that's the furthest of the inner solar system. Then you got gas dwarf out here. This is where you're starting to enter the outer solar system. You got banded there, and then obviously to the gas giants and onwards. So yeah, the inner planets are really where we want to keep an eye on. So anything closer than the gas dwarf is what we want to keep an eye on at the moment. So there we are. Let's continue running the simulation though. Let time evolve. And let's see how the orbits change. So let's continue. So remember the orbits we could still see an interference with the orbits. So just have to wait and see how stuff changes really. So there you go. But what we need to do as well, I think the star itself is probably going to have to be, we're going to have to boost the star at some point here. So what we'll do is, those two inner planet orbits, they could in theory face a collision eventually. I mean, you can see this kind of reminds me of Earth and Sirius. You can see the two inner planets, the red one and then the brown orbit, they kind of blend in together. So if they blend together at the wrong time, we could see an ejection, we could see a collision, who knows. But yeah, those inner planet orbits don't look the most comfortable in there, so that's not looking good. But what we'll do is we need to save the simulation, as we're going to boost the star's stats now. So what we need to do is, I think you need to boost the radius. So let's give it a little increase. Oh, well, that's not what we wanted. What happened there? Oh, that is very strange. Okay, let's open that again. The stars at the moment, very, very glitchy. So you do have to be careful. That's why we save simulations, because that is very strange. Okay, so what do we need to do? I think we need to just increase the the temperature. Yeah, okay, so let's play. Increase the temperature a bit. So as we can see, that increases our luminosity. So as this star eventually enters the blue phase, temperature. So now we can see it's at 238 luminosity. So that is a lot bigger. Look at that orbit now. So we can see the inner planets now. We've taken a big jump in evolution, so we can see it. The inner planets are not looking good now. Where's Capturn B? Yeah, 87. So we're now passing the habitable stage for Capturn there. So anything closer than that's not good. How's this world doing? -8 degrees. Okay, so it's warming up. So that one's actually entering the comfortable temperatures now. How's Kepler doing as well? We should. That's at 90 degrees. I don't know why it's frozen. Let's actually just melt it all. That's what it should look like. So there we go. So yeah, very, very blue ocean world there. Further out, obviously, this world here, the next planet out. So the outer solar system sort of begins there. So yeah, Kepler 22b is pretty much the last of the inner planets. So how are we doing here? So where's its clouds gone? There should be clouds on here. That's rather weird. I think it's just because it's so hot, the clouds aren't really showing up. So yeah, there it is. So it is cooling down a bit though. Let's put it to 0 degrees. Maybe that will show them. No, you can see how quick it increases though. So yeah, this planet, pretty crazy stuff. Yeah, you can see there is white clouds under there, but yeah, there's a very, very blue ocean. So yeah, even Kepler 22b, that's getting too warm. How's this world doing here? Okay, so the best bet is probably this planet now. As we can see, it's still getting to some warmer temperatures. I think it may be tidally locked as well. I'm not sure, but we can see it's not really rotating, but it's sitting roughly in that comfortable temperatures. It is decreasing and stuff though, so it's got some weird stuff going on. But yeah, that's definitely the best place for life currently in the system. Now we've evolved, so you can see the stats there. It has got life stats, so pretty good. Okay, so how are we doing in the, so where were we? So Earth-like, how are you doing? So yeah, it says -50 now. What's going on there? Has the star, like, decreased in radius or something? What's going on there? It's rather bizarre. Why is it getting colder? What the heck? That is very strange. Look at that. That's weird. Let's actually just open that again before we did that. Is that just a glitch or what? What's that all about? Why is it getting colder? Because this is a simulation before we increase the star. Look at Earth-like. Where is it? The Captain B, Earth-like. Where are you? Earth-like? Where is it? This one. So this one was at -60, and I think it was warming up. Yeah. So this. Well, no, it was still getting cold in the last one as well. That's really weird how it's doing that. Okay, so let's increase the star though. I mean, the game is not really. Yeah, it's a bit buggy. So let's increase this up. So we want us around. Let's go to even further than when we were before. So. I don't know, 300 AU of the sun now, so that's getting crazier. We need to increase the radius as well. Will it let us do that? Okay, so we're going to have to do that slightly differently. Okay, so let's sell it. So look at the luminosity break in there. That's so weird. But we want to make it a little bigger, you know, so something like that. I mean, I don't know. But we need some luminosity game. I don't know why the luminosity is suddenly doing that. So that's really, really weird how it does that. See, look at that. I want to make my star bigger, and it just doesn't let me. So how annoying is that? I mean, that is just... Game, behave yourself, come on. That is very frustrating. So increase the star. Look, so increasing the star actually makes it mess up all of its stats. So that is so strange. So I click play, it just fades out. How annoying is that? That is so strange. So I put it to that temperature. That breaks it. So yeah, we need to... I think the temperature is probably the best area we need to play with here. So... Okay, so let's do that again. So we want to increase our star. So we're just going to do that. So that does it that way. But it still doesn't change the radius of our star. So what if I... So I don't really know how to do this. Because if I lock the radius, then I can't do anything else. So... See, that just breaks. That just completely breaks it if I do that. So... That's rather weird, but yeah, give me a sec, guys, and I'll be back with you once I've figured it out. Okay, everyone, so I've actually had to do a complete overhaul of the star in the system, because basically the system, it wouldn't let me advance any further. I spent about 30 minutes trying to get the star to work, but every time I made it bigger or changed the stat, it just disappeared and it broke. So in theory, it was stopping us from actually advancing in the episode. So what I've done is I've had to actually use auto orbit, so it's actually upset all of our orbits, which is very, very annoying. But it's the only way we can actually proceed here. So I'm now using Rigel as our main star, because it's letting me customize its stats a little easier. So I'm hoping it will hold out, but I need to make it bigger is the main thing. It's got a luminosity of roughly 10,000 now, so I've made it a lot brighter. So yeah, to be honest, guys, you didn't miss much in between the last part and now. I mean, all I did was make the star bigger, and obviously all of the Earth-like worlds are now burning hot. That's the only thing you've really missed. So yeah, apologies for that, but there's literally nothing I can do with the game's stability problem at the moment. So yeah, there we go. What we're going to do is we're going to slow down time. Now I'm hoping it's going to let me make it bigger. That's what I really want to do here is, yeah. Okay, so I want to make the star bigger, a lot bigger. So hopefully it will let me, yes, okay. So this is what we want. We want our star to get bigger. And as you can see, as it gets bigger, it's getting colder as it's becoming a red giant. So now we're in the early red giant phase. So we can see the star's getting bigger. So yeah, we're using Rigel. Just ignore the name, but pretend it's the same star. That's all we can do at this point. So there we go. So we're now into the early red giant phase. So our star's got very, very big. The luminosity is at 12,000 suns now as we've made our star bigger. Surface temperature has cooled down now as the star... It's gone through the blue giant phase, but now as it's getting older, it's starting to lose temperature as it's starting to burn more helium rather than hydrogen. As it's running out of hydrogen and fuel. So there we are. So now if we look at the system, how we do. So you can see the orbits are still actually inclining a bit. But yeah, there we are. It looks like that Kepler planet, it did have a very inclined orbit. And you also have this object over here, which just got absolutely ruined. But yeah, there you go. So we'll let the simulation just play out for a long time now, because I want the orbits to kind of balance themselves out again, because it was quite annoying how they did that. So there we are. So the sun, or the star, is now... Yeah, early red giant phase. How are we doing at the closest planet here? I'm guessing it's not looking good. Yeah, 2,300 degrees on this planet now. So no more hot clouds. This was one of those red clouds, remember? And then we also had a, while you guys were, or while I cut the video, the other inner planet evaporated completely. It completely disappeared and vanished. So pretty crazy stuff. Hot ice. Yep, absolutely mental there as well. Next planet out, Alombi. That was the desert planet. Also just completely gone. Venus. That world is still hanging on 700 degrees. I think what we need to do to it, though, is atmosphere colour needs to go full-on Venus colour now. So there you are. There is that. Next planet out as well. This planet's still hanging on. It's still very, very hot there. It's blue colour. I don't think it deserves its blue colour anymore, I have to say. I mean, its atmosphere is not even showing up on the customization there. So I don't know how its atmosphere is even still showing, which is weird. But yeah, there's that one. That's where I was so to them. Okay, so next planet out, Capturn B. Again, just too hot. A planet that was once a safe haven for life. You got Earth-like as well. Also, a planet that once was life and habitable. Nope. And then the next planet out, this planet, yep, lost its atmosphere completely, probably due to the solar winds. Kepler 22b, an ocean world, no more at all. Gas dwarf, how are we doing out here? Next planet out, 400 degrees at the gas dwarf. Then we have Banded 27, the first of the outer sort of solar system, 300 degrees there. We'll take a big jump now. How's Neptune doing? Minus 25. So yeah, it got down to minus 11 there. So you can see it's yeah, not looking good at all on that planet there. So we can see very, very dangerous star we have got rolling here. So I think what we're gonna have to do as well, we're gonna have to make it bigger. So what we'll do is we'll save the simulation. Now we're gonna start going into the real serious red giant phases here. So we're going to probably go for a red supergiant. So probably around 1 to 2, maybe 3 AU in size before it goes pop. So now let's let the simulation run. So there we are. Okay. Oh god, right, there you go. Slow down. There you go. Okay, so Rigel, you're going to have to get bigger, my friend. 0.4 AU. Here we go. It's increasing. Bigger and bigger. So it's losing surface temperature as it gets bigger as well. So there we go. That's how it should be. So we can see the closest planet to the star. It's going to fall in the star eventually. And it's gone. It's been destroyed. So as our star grows. There you go. So 1.3 AU. There you go. It's getting a little bigger. It's going to peak and it's gone. Okay, so that's roughly where we're going to have to put it to. So it's annoying it's done that, but obviously that's why we save our simulation. So it pops around 1.4 AU. So that's how big our star will roughly get then. Okay, good to know. So what we'll do now is, for instance, we'll watch that action-packed adventure again. So what we'll do is we'll double it. There you go. So that completely... Oh, it actually ejected the planet this time, but as we saw it was supposed to eat it. It's only because we made it bigger all at once. We can see now we're actually letting the simulation run a bit. It's really, really distorting the orbits in the inner system here now because we were running the simulation a lot faster than we were before. So look how it has done. Look what it's done to the inner systems. It's completely destabilized. Probably the first 4 planets maybe there. So that's not looking good. And what we'll do is we'll continue increasing. So 1.4 is roughly the exploding limit. So we'll just see how far we can. So we'll put it around to 1.3. Okay, 1.23 that time. Okay, so it looks like the star's explosion limit could be a random number. So to try and get it exactly where we want it may not be possible. So what we're going to do this time is we're just going to make it bigger. So 1.3. Can it hold 1.3? Okay, so that's that. We're not going to go any bigger than that. That's it. That's as large as we're going to give it. So where did that... so that got ejected again, but as we know, it would have been destroyed. Okay, so this is the final sort of stage before detonation. So save, thank you very much. Okay, there you go. So birth to death, we're now at the complete death stage of this system. So there we are. Okay, right, so there's only a few more things we can do now. So it's right on the edge of destruction, the star. If we make it any bigger, it will explode. We are going to go supernova here as well because this star is definitely large enough. It's a... Yeah, we did plan it as a supergiant. I think it's large enough. 1.3 AU. It's larger than the red giant sun. If we're going to compare it to some of the titans of the star family, though, I mean, it's no UI Scuti or Canis Majoris, for instance. It's not on the level there, but it's a lot bigger than obviously the red giant sun would be. And there's Stephenson, so it's nowhere near the largest, but it's still a considerably good size. So there you are. But we can see this orbit here, hot ice, is right on the edge of destruction. Look how its orbit rotates. It gets very, very close to the star. I mean, that is a completely broken orbit there. So there you are. Let's continue the simulation running. So that is absolutely crazy. So there you go. So this is the system in its real final stages here. So it's, yeah, 1,400 degrees there. That is insane. So there you go. Right, so I think what we need to do now is also we need to detonate. So the way we have to do this is we have to place a white dwarf in the middle of this star, and then we have to blow the star up on top of it. That's the only way I've sort of figured it out to work. Well, I say white dwarf. In theory, it could be black hole or a pulsar, but I think we'll go black hole this time because we haven't done a black hole before, and we always do white dwarf and stuff. So we're going to need to put a black hole inside this thing. So what we're going to need to do is, so it's 11 masses of sun, the star currently. So obviously when it blows up, it's going to lose a lot of that mass. So I'm thinking a 1 solar mass black hole in there, maybe? Something like that, black hole. So formed from the destruction of the star, we're going to put a black hole in the middle. So obviously now this star's going to collapse down, form the black hole. But now what we also need to do is tools, explode. Where's explode? Explode the star. Okay, so that's a star that's going to go boom. Then we need to auto-orbit, obviously, because they need to orbit the black hole now. And obviously we need to delete the remains of the star. Okay, so the black hole's now formed in the middle. Auto-orbit around the black hole, please. There you go. So that is, yeah, Nova time. Look at that. Oh, that is awesome. So we're going to let this. We're going to let it play out nice and slowly, so we can watch the destruction of this system. So slow it down. Okay, there you go. Okay, oh my god, okay, it's a big explosion there. We're travelling at 0.9 seconds. So obviously all the planets are going to remain orbiting around the black hole if they survive the nova. But there you go. So obviously star, explode, supernova time. Let the simulation run faster now. because I'm not expecting these planets in the inner. I don't think they're going to make it. I mean, yeah, they are absolutely going to get roasted by that. So let's let it play out. So there you go, supernova. There you can see it's gone. It's completely gone. Yeah, so the inner solar system, all those inner planets are going to evaporate. I mean, I'm expecting the gas giants to probably hang on here, but all of the dwarf planets, anything made of rock, probably not. But remember, it is a supernova, so it could destroy everything. So there you go. I mean, that is a big explosion there. You got this planet on the edge. I don't know if it will make it, but there you go. So supernova out. Don't know if anything's even still. So Neptune's actually survived it. Okay, so there you go. So that's it. Okay, so what is left in here? So black hole is now in a binary with Kepler 22b. So Kepler 22b has managed to survive the destruction of the system. So there you go. So now let's let the simulation evolve past the star's destruction and see where we end up, really. So supernova all gone. We're now in the darkness of space. You can see the galaxy behind us. So that is kind of where we are now. So this, in theory, will start to... Actually, in theory, yeah, we can go past the star's phases. We'll save and override that, so we're never going back. So our star has exploded. Black hole. So now we have to sort of see how this is going to... In this simulation, remember, a black hole could live for a long time, but we can see as time passes, stuff is going to break. Orbit decay, remember, orbit decay, stuff like that. Kepler 22b, it's obviously had an interaction with one of the gas giants, which has upset the binary orbit. So that binary orbit is now broken. It's destabilized the whole system. So... yeah, the remains, you can see roughly stuff still orbiting where the black hole in the middle is, or it's still the most dominant object, but it's having a lot of interactions with one of the other objects by the looks of things now. I'm not exactly sure which one. So there you go, there's a rough sort of indicator of thing that's going. So you can see most of the planets are still orbiting it nicely, but yeah, there you are. So let's just let time pass as much as possible. I mean, eventually these orbits are going to break. They could fall into the black hole, for instance, they could break away, but I think for fun, we're going to make the orbits dissolve inwards. I think that's going to be, I think that would be the best thing to do here. So, yeah, remember, for a black hole to evaporate, that's going to take a very, very long time. We're talking serious numbers here. So, for instance, we're just going to skip that long wait, and we're going to slowly start to break things down. So, what we're going to do is, I think we're going to have to halt all velocities. I think that could be good, because then everything's going to spiral in, which is a possibility. Some stuff could just break away. Some stuff could just shoot off. But what we're going to do is we're going to halt just for a bit of fun. So I'm guessing most stuff will just fall in the black hole. I'm not exactly sure, but orbit decay, this is what happens. Some objects are going to crash into the star. Some of them escaped, actually. I guess that was a good thing, because some of them definitely crashed into it there. I saw the orbit just fly in. So that's it, really. And then obviously black hole... eventually the black hole's going to evaporate. So I know someone was actually asking me the other day on one of the live streams we did. On that live stream I did, but you know, some people have said, have you ever blown up a black hole? So for anyone who hasn't seen that, here you go. So pop, there you go. That's a black hole exploding, everyone. Look at that. So after it, you remember, this is after a very, very long period of time where a black hole would just evaporate due to Hawking radiation. So in theory, this is in a very, very far future where this is going to pop. But I don't even know what's going on here. Oh, it looks awesome though. Look at this. Black hole explosion. And it's gone. Just dissolved via Hawking radiation. So there you go. And obviously by this point, there wouldn't be any galaxy anymore. We'd just be in the darkness of space. I mean, there wouldn't be much left at this point. So that's probably roughly what you'd have. And then there'd be a few objects still remaining out there somewhere, but these would all be eventually sucked up by other black holes. But the planets would, in theory, disappear by proton decay eventually. So yeah, there you go. I think that does it for the end of this system. So I mean, we did have some survivors, but I mean, the system as a whole is just no more. So there you go, guys. Hopefully you all enjoyed this part 2 of evolving a custom system from birth to death. Apologies for having to skip out a lot of bits and bobs though, but yeah, the game is very, very unstable, and it's not possible to just do it like we normally would. So I think for the next one of these I do, I'm going to hop back to good old update 23 where everything was functioning perfectly. So yeah, stay tuned for that. And also, if you've got any ideas of what we could do in the next evolving solar system part, and let me know what you want to see, like how many stars, any certain planets, how many planets do you want, how close are the planets, like let me know those sort of things. But yeah, with all that said and done, guys, hopefully you will enjoy this video, and if you did, press that like button, subscribe for more, help us on the journey to 23,000 subscribers now. And yeah, guys, make sure you have a great day, stay safe out there, and I'll see you in the next video. Goodbye.